Right, session 2, velocity and acceleration. State the definition of a scalar quantity. A quantity that has size only. State the definition of a vector quantity. A quantity that has size and direction. Explain the difference between vector and scalar quantities. That's just the same as above. A vector has a size and direction. A scalar has only a size. Sort the following into scalar and vector terms. I'll do the scalars in red. Displacement, that has size and direction, so that's a vector. Distance, that's just a size, that's a scalar. Velocity has size and direction. Speed only has a size. Acceleration's got size and direction. Force has a size and direction. Weight has size and direction. Mass only has size. Momentum has size and direction. Energy only has size. So the rest of them, they were vectors. State the definitions of speed and velocity. Well, speed equals distance divided by time. So if you travel a distance of 1 meter in 1 second, you'll be travelling at a speed of 1 meter per second. So it's how far you travel in a certain amount of time. Velocity, same as speed, but with a direction. How far you travel per second in a direction. Recall the speed equation. Speed equals distance divided by time. The car travels 2 kilometers, which is 2,000 meters, in 2 minutes, which is 120 seconds. What speed does it travel at? Speed equals distance divided by time. So that equals 2,000 meters in 120 seconds. That equals 16.7 meters per second. How can you calculate speed from a distance time graph? Well, if you've got distance up the side, time along the bottom, the gradient is going to be distance divided by time, which equals speed. So the speed equals the gradient. Recall the acceleration equation. Acceleration equals change in velocity, so delta v, which means change in velocity, divided by time. A runner accelerates from 0 to 4 meters a second in 20 seconds. What's their acceleration? So acceleration, the change in speeds from 0 to 4, so that's 4 meters per second, and that's changed in 20 seconds, so that's 0.2 meters per second squared. A train is travelling at 50 meters per second. It accelerates at 2 meters per second squared. How fast will it be travelling? In 10 meters. So we'll use this equation here. This is the final velocity. This is the initial velocity. A is the acceleration, and S is the distance. So V squared equals U squared. So it's travelling at 50 meters per second, so let's square that bad boy. And we need to add that to 2 times by the acceleration, which is 2, times by the distance, which is 10. So that's going to be 2,500 plus 2 times by 2 is 4, times by 10 is 40. It's going to be 2,540. But remember, that's V squared. So therefore, 3 dots means therefore V is going to be the square root of 2,540, which equals 50.4 meters per second. How can you calculate acceleration from a velocity time graph? So if we do velocity time, have a look at the gradient. So the gradient will be velocity over time, because it's always y divided by x. Velocity over time, and the velocity is changing. So that's the change of velocity over time, that'll be the acceleration. So it's the gradient. You can calculate acceleration from a velocity time graph by getting the gradient. How can you calculate distance travelled from a velocity time graph? Well, that's the area under the graph. Describe 2 ways to determine the speed of an object. Well, to get the speed, and do the distance divided by the time. So see how far it's travelled, see how long it took. Or to get the speed, if it's a wave, you can do the frequency times by the wavelength. What are the typical speeds of wind, sound, walking, running, cycling, and a car around town, and a car around a motorway, and a ferry, a train, commuter, train high speed, and an airliner? I'm not sure about wind, I'll be honest. Say about 10 metres a second. Depends if it's a strong wind or a soft wind. Sound's 330 metres per second. Walking, depends if it's fast or slow walking. Slow walking, 1 metre a second. Fast walking, 2 metres a second. Running, depends if you're an Olympic athlete or not. Is it running or is it sprinting? Well, if you're just running like a jog, say 5 metres a second. Cycling, well, 10 metres a second. Car around town, well, depends what the traffic's like. It's like cycling, isn't it? 10 metres a second. Car on a motorway, 70 miles per hour. Flat out. Ferry, I don't know, about 20 metres a second once they get going. I've never seen these fast. Train commuter, I don't know, 40 miles per hour. Train high speed, again about 70 miles an hour, 80 miles per hour, something like that. Airliner, 200 miles per hour. You have to check those figures, I've totally made some of them up. What is the acceleration due to gravity? 10 metres per second squared, which means an increase of 10 metres per second in your speed per second. The distance time graph for a car is shown below. Describe what the graph shows about the speed of the car as it travels the 80 metres. Right, let's break it down. Steady speed here, and then it's slowing down there. Okay. This is fast and steady. This is slower. Now it's difficult to see. Do you think it's getting flatter and flatter, or is it fairly steady there? I think it's a straight line-ish, so that's slower and steady. And this part here is when it's slowing down. The graph shows how the velocity of a small car changes with time. Use the graph to estimate the velocity of the car at 3 seconds. Right, 3 seconds, there's your time along the bottom, velocity up there. 3 seconds is about there. So the velocity, I would say, is about 11 metres per second. Calculate the acceleration of the car when it is speeding up. Right, well, it's speeding up across this part of the journey, and then it's going at a steady speed at this part of the journey. Look at that, 20 metres per second, and it's not changing. And here, the velocity is decreasing. Alright? Alright, velocity is decreasing there. So the acceleration part, we're looking for this gradient. So the acceleration equals the change in the velocity for that particular section divided by the time. So it's gone from 0 metres a second up to 20. So it's changed by 20 metres a second. and it did that change in 5 seconds. So 20 divided by 5 is 4. So that's 4 meters per second squared. And that's the end of session 2, velocity and acceleration. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now. Work hard and be nice.